This is Lesson 3, but Mass Doesn't, from the Investigating Chemistry unit. You're going to start this with a review of physical and chemical changes that you discussed in Lesson 1 and Lesson 2. And you're going to start with one more experiment today. You're going to tell the students that you have a secret message for them and that we're going to use chemical changes in order to reveal the secret message. So you'll start with a piece of the yellow paper from the kit and make sure that you've used a yellow crayon to write on it so that they cannot read what the message is. You're going to talk about how you're going to use 2 different liquids in order to reveal the message and see if you can make a chemical change occur. So you'll start with a solution of baking soda and water, and you're going to use that on a paper towel. And then wipe that over the paper, and you will see the color change on the paper pretty quickly. And as it dries, it will continue to get even a little bit darker, and the difference will show a little bit more. In explaining why this is happening to the students, you can explain that it has to do with acids and bases and how those react with the ink in the paper and how those cause a chemical reaction or a chemical change to occur. To reverse this, they'll just use a paper towel with a little bit of vinegar. And as you wipe the vinegar on, that will change the chemical reaction. And you'll see that as you add the vinegar, it's going to take away that darker red that was there. And I'll take a minute of doing that, and then your hidden message will be hidden once again. And you're going to allow students to do this using, they can use the yellow crayons like we used. They can also use soap. There are pieces of soap in the kit that they can use the soap to make their secret messages as well. The next part of this is going to be building a balance scale and then using it to find mass and talk about how mass does not change even when volume does. You're going to start by having students build their own balance scale. You will use this again later in the unit, so please make sure that there is a place to store it. I would recommend going through the steps one time on your own of creating them and then creating them step by step with the students. The directions are in the workbook. It's not a difficult process, but it does have a lot of steps, so it's probably something that's best done with students staying with you and not working ahead. If you do science rotations, you could even do this small group as a rotation. So just a couple of ways to hopefully make that go a little more smoothly. If you're doing this lesson in 2 parts, you can stop today after you have finished building the balance scale, and then you'll use the balance scale in the second part of the lesson. For the second part of the lesson, you are going to have the students use the balance scale to talk about how you find mass and measuring whether mass changes after other changes have occurred. The first thing you're going to want to talk about is what's the difference between mass and weight, and how mass is essentially how much stuff something has, and weight is measuring the effects of gravity. So you can talk about how on a trip to the moon, our mass would not change. We're made up of as much stuff as we were on Earth once we're on the moon. But our weight would definitely change because the moon has less gravitational pull, so we're not experiencing the same amount of gravity, so our weight would go down. That fluctuates, but mass does not. The students are now going to work on an experiment where they're going to use the balance scale that they made, and they're going to find the mass of different substances. So the first thing that they'll want to do is use the graduated cups, and you're going to talk about the precision of measurement, and they're going to use the cups to determine the volume that they have. So they're going to first need to measure 10 milliliters of salt, and they'll also need to measure 10 milliliters of water. They're going to find the mass using their balance scale. I'm holding it up for demonstration, but for actually using it in class, they can hang it off of their desk or hang it off of a table or just any other surface that they could hang this from. So what they'll do is put their 10 milliliters of salt in 1 cup, and then they're going to use the washers and count the washers as they balance it to determine the mass of the 10 milliliters of salt. This is also easier on a table where they can kind of get down to eye level and determine if things are balanced. Once they found the mass of the 10 milliliters of salt, they will repeat that with the 10 milliliters of water. Tell them they'll want to be careful in this part to make sure that they don't spill the water. The mass won't change. Everything in that cup is still the same. It's just it gets messy and it's a little harder to clean up, and harder to move on to the next part of the lesson. So again, they're going to use the washers to find the mass of the water. And then they will record this in their student workbook as well. The next thing we're going to do is combine the water and the salt. And they'll mix this up. And they will look at what the volume is first. And the first thing that you may want to talk about is why 10 milliliters of water and 10 milliliters of salt did not change this into 20 milliliters of a liquid. That this isn't a case where 1 plus 1 equals 2 or 10 plus 10 equals 20. So they'll want to mix that. They'll want to look at the volume. And then they're going to find the mass of this now that they've combined the two. An easy step to forget that we need to remind them of is that they do need to put that other graduated cup in the balance as well, because when they were finding the mass before, there were 2 graduated cups involved. So they need to still have 2 graduated cups involved. And then they're going to use these again. And they'll need to add more washers. And they can add and remove as they need until they have it balanced. And what they'll find is that the mass did not change. This mass is equal to the sum of the 2 individual masses that they had already found. So this is showing that while the volume changed and didn't come to the sum of the 2 original volumes, the mass did not change. There's the same amount of mass in this cup as there was when we measured independently. So that's one way for them to experiment with that and see that. And make sure that they are recording all of their observations in their workbook as they're working through this. The next activity in this lesson is going to have students using the balance scale again to measure mass and compare that to how that changes or doesn't change compared to volume changing or not changing. So for this, students are going to start with a container that has 1 milliliter of sodium polyacrylate that you've already provided for them. And they're going to start by finding the mass of that. Again, using the washers to find that mass. They'll balance it appropriately. And then they're going to record that into their student workbook. The next thing they'll need to do is measure out 10 milliliters of water, and they're going to find the mass of that. Even though we just did this a few minutes ago in the first part of the lesson, they do need to, again, measure to find the mass, because if their measurements were more precise one time versus the other, or if they weren't as accurate as they could have been in using the balance scale that first time, the numbers may be slightly different. And if they are, we want to make sure that we've got them correct for this activity. So once they've found the mass of both parts by themselves, tell the students that they can go ahead and pour the water into the larger cup. This is one of those lots of oohs and ahs moments. They'll pour it in, and they're going to quickly see a dramatic change in the volume as that expands when it absorbs the water and nearly takes up the entire cup. So right away they're going to see we've got a much bigger difference in the volume. It's about 4 times right now what the volume was before. I'm going to back up that part. So right away they're going to see that there is a dramatic change in the volume, and they've gone from about 1 milliliter to about 40 milliliters of volume in this cup, just by adding the 10 milliliters of water. So the next thing they need to do is they need to measure the mass of this, and hopefully they're going to remember from the first lesson, but if not, you can remind them they need to use that empty graduated cup as well, because that was part of what was measured the first time around. And then they're going to use their washers and their balance scale to find the mass of this. And students are likely going to be very surprised to find that even though the volume changed dramatically, the mass didn't. It's a great way, again, to illustrate that how much stuff is in something doesn't change, even when we have a physical change, like the way that the water reacted with the sodium polyacrylate. Students have some places in their workbook that they can answer questions about this experiment, and they can also do the reading activities and math activities that incorporate the Common Core state standards into this. And again, remember, you need to have somewhere safe to save the balance scales because they will be used again later in this unit. Thank you.